follow directly from the theorem? Let's say if I go backwards and show you the theorem. How does the corollary follow from the theorem? So what was the corollary? If A divides, let me change the color. Okay, so what did the corollary say? If A divides B, and A divides C, then A divides MB plus NC, صح؟
صح.
يلا يا شباب. I need somebody to tell me how do we prove this?
Can we just prove by contradiction and bring a counter example?
You're thinking counter example. شو دخل contradiction بالcounter example? These are two different things, by the way. These are two different things. No, here this is the direct proof based on theorem 1. If A divides B and A divides C, then A divides any linear combination of B and C, MB plus NC, where M and N are integers.
Doctor, isn't it the theorem 1 and 2 combined?
You mean part 1 and 2 from theorem 1?
Doctor,
Yes.
I don't see anything.
You don't see, يا شباب, you don't see anything?
لا
we can
see
the slide.
I see a theorem 1 slide.
Yes.
I see
on the
nothing.
theorem 1 slide.
I see the proof slide.
جرب تطلع وتدخل مرة ثانية.
I see the question.
جربت.
You see what?
The theorem 1.
Yeah, أيوة, theorem 1. I am at theorem 1.
أنا صراحة ما أشوف شيء أبد. حتى لما أسوي لك بند.
طيب go back and come back. Go and come back. طيب, we'll see how we can solve this problem, because this is والله a big problem يعني. طيب, so يلا يا شباب. Somebody said I need to combine. It is combining 1 and 2. طيب, how do I combine 1 and 2? Any ideas?
I think, Doctor, if we can say that any multiple of the dividend can be divided by the divider, right?
Well, this is what it says, but I need the proof. How do I prove it?
We start from the left-hand side. A divides B. It means B can be written as an integer multiplied by A.
No, this is you're using the definition, and I'm telling you there is a much easier proof by looking at the theorem. Just use the theorem. Just use the theorem يا شباب.
It's the first part of the theorem, but multiplied by extra integer.
Well, how do you reach? That's the question. How do I prove this? How do
دكتور
I
ممكن
prove this?
نقدر نخلي NC يساوي انتجر
NC
بعدين
يساوي
ايه مثلا نخليه نيو انتجر.
يعني يا دكتور you can say if A divides C and A divides B it means that N or B equals N times C, which is a constant.
You're not
You get
using
what
the
I
theorem.
mean?
You're not using. I want you to use the theorem, ya shabab. I want you to use the theorem. I need somebody to tell me how do you use this theorem in proving that if A divides B and A divides C, then A divides MB plus NC.
We have that the M and N are all integers, right?
Yes, yes, we are given that M and N are integers.
Since theorem 2 here says that A divides B, then A divides BC, so it's the same with any other integer, with a
Exactly.
C and anything.
Very good.
And
so from number two, if A divides B, then A divides MB. صح ولا لا؟
yes.
طيب. Next.
And with the first one, since A divides B and A divides C, then A divides the sum of B and C. Then we can just sum it like BC. So we can go to the point that A divides MB and A divides NC, so we can just sum it. So A divides MB plus NC.
Allah يفتح عليك. Now you're talking. So A divides B implies A divides MB. This is from number 2. A divides C implies A divides NC. This is by number 2. صح? So now A divides MB. I'm given or I have proved using number 2 that A divides MB and A divides NC. صح? So if A divides MB, A divides NC, then it will divide the addition. It will divide the MB plus the NC, and this is by part 1. Okay, and this is by part 1 of the theorem, which is this one, right? If A divides B and A divides, then A divides B plus C. So I will leave you, you will write it, okay? You will write the proof of the corollary, okay? Right. Okay, right. Now for question 6, show that if A are integers where A is not equal to 0, such that A divides C and B divides D, then AB divides CD. What do you think the best way to prove this?
I believe we will use the same theorem, but the third part of it.
The third part of it? How are you going to use the third part of it? It says if A divides B and B divides C, then A divides C.
Then wait, can you go back to the question again?
Sure.
ACBT.
If A divides C and B divides D, then AB divides CD. Well, in this case, ya shabab, try the direct proof. Okay? Because the theorem does not seem to be applying here, right? I do not see anywhere where I can multiply and get the result. So what I will do is, since A divides C, then there exists I integer such that C is equal to IA. صح? Since B divides D, then there exists an integer J such that D is equal to J times B. Okay. طيب. Now, who can tell me what do I want to show?
AB divides CD.
Which is what?
The combination of the two equations.
To show that there exists an integer K, صح?
Yes.
There exists an integer K such that CD is equal to K multiplied by AB.
AB. Yeah.
Right. Now the question is, how do I do that?
Multiply the two equations.
It's as simple as multiplying the two equations. So multiplying 1 and 2, basically, what is the value of C? What is the value of D? Well, multiply C by D, right? Multiplying 1 and 2, we get C times D is nothing but IA multiplied by JB. Right.
It's KAB.
What is K?
K equal to I
by
times
J.
J.
Is I times J. الله يفتح عليكم. So I times J. ليش هيك طلعت السهم؟ Okay, so IJ multiplied by AB. IJ multiplied by AB. And of course, IJ is an integer, صح? Because I is an integer, J is an integer, IJ is an integer. So CD, so therefore, hence K is equal to H. K is equal to IJ, and therefore AB divides CD. AB divides CD. Any question يا شباب? Any question?
No.
إذا سمحت دكتور آسف but
تفضل.
what is the symbol before ST?
What is the symbol before ST? I don't even see ST. When هل ST?
Such
that
that.
Z. This one? This one?
Yes.
Z, the set of integers.
Oh, I see. Thank you.
Okay. تمام يا شباب؟ طيب.
Yeah.
Okay. So let's now come to the division algorithm. Now it is called division algorithm only, you know, for historical reasons. But let's go over it and let's see what is it all about. So it says here, let A be an integer, okay, and D a positive integer, okay. So A could be negative, right? But D has to be a positive integer. Then there are unique integers Q and R with R greater than or equal to 0, strictly less than D, such that A is equal to DQ plus R, such that A is equal to DQ plus R. So before we proceed, let me just give you an example that shows, you know, what do we mean by, or what does this theorem talk about, okay? And then we will, and then we will proceed. So first, we would like to choose an integer A and a positive integer D, and a positive integer D. So let's assume that, so let for example, A equal 21, and let D equal 6. Okay, so A is equal to 21, D is equal to 6. A is equal to 21, D is equal to 6. Right. Now, what does the theorem say? The theorem says that for 21 and for D is equal to 6, there, oops, what happened? Okay, for A equal 21, D equal to 6, then there are unique integers Q and R with R greater than or equal to 0, less than D, such that A equal DQ plus R. So, so there are Q and R such that A, which is 21, is equal to D multiplied by Q, 6, multiplied by Q, plus R. And R is such that it is strictly less than 6. So R is strictly less than 6, greater than or equal to 0. Now, can anybody tell me what is the value of Q and R in this case?
3 and 3.
3 and 3. Let's check. So let's put 3 here and let's put 3 here. Right. So is it true that 6 multiplied by 3 plus 3 is equal to 21, and this second 3 is such that it is greater than or equal to 0, less than 6?
Yes.
Yes. Now, do you know what is this 3 and what is that 3?
Is the floor of the division, and 3 is the remainder of the division.
And 3 is the remainder of the division. So the first one is the floor of the division of, or it is actually called the quotient. Okay, it is actually called the quotient, and the second one is called the remainder. The second one is called the remainder. So A is equal to DQ. Q is the quotient plus R. R is the remainder. Now, A is called the dividend and D is the divisor. Well, we're not going to use A and D a lot. The more that we are going to use is actually Q and R. Okay, the more that we are going to use is actually Q and R. Now, the proof of the division algorithm is basically using the well-ordering property by strong induction, but we'll not do the proof. Okay, you'll not be responsible for doing the proof. Okay, so therefore the quotient is basically A div D, and the remainder is A mod D. Okay, the quotient is A div D and the remainder is A mod D. So this is called the quotient, this is called the remainder. Any question on the division algorithm? Right, let's take these two examples. Now, who can tell me what is the quotient and the remainder of 19 when divided by 7? So in this case, what is the value of Q? What is the value of R? On the chat, ya shabab. Write Q equal, R equal. So 2 and 5. صح? 2 and 5. Why? So Q is equal to 2 and R is equal to okay, and R is equal to 5. So indeed 2 multiplied by 7 plus 5 is equal to basically 14 plus 5, which is the 19. Okay, which is the 19. On the chat, first of all, is this a correct question? You know, what is the quotient and remainder when minus 111 is divided by 11?
Yes.
Yes,
11
it is.
should be
Supposed to be
Because
positive.
the only thing that needs to be positive is what?
Remainder.
Not the remainder. Well, the remainder is after you do the divisions, huh? But
Yes.
but basically it's the D, which is in our case it's the 11. صح ولا لا?
Yes.
It's the 11. طيب يلا يا شباب on the chat.
Why,
What
Doctor?
is- huh?
Why does the denominator have to be a positive number?
It has to be يعني it has to be a positive because we are going to build on it modular arithmetic. D has to be positive.
So in our case here, not
Yeah.
in general.
No, حتى in general D has to be positive.
بس ممكن يعني يسمونه هذا يعني يقسم 111 على سالب 11 ولا اقلب
But that will not be considered part of modular arithmetic.
So
and of course I can divide by a negative number. But now we're talking about quotient and remainder with respect to a specific value D, right? So that D has to be positive because R, the remainder, is going to be greater than or equal to 0, strictly less than D. Okay, strictly less than D. Fine. So let me just go through the what's wrong with the answer minus 10 minus 1? What's wrong with the
R
bigger than
is
0.
less than 0.
See, R cannot be less than 0. R cannot be less than 0. I understand that what you did in order to solve part B was that you said, well, minus 111 is equal to 10 is equal to minus 10, صح? Multiplied by 11. So this will give how much? Minus 110, صح? طيب. To become minus 111, what do I need to do? I need to subtract 1. Huh? So that's why when some of you have put, minus 10 and minus 1, well, minus 10 and minus 1 will satisfy the equation, صح? But it will not satisfy the restriction. The restriction that R should be greater than or equal to 0, less than 11. In my case here, R is minus 1. طيب. From this equation, can anybody tell me how can I fix it? Such that R becomes greater than or equal to 0?
Make it minus 11 instead of minus 10.
Minus 1 as a factor? Common factor?
Minus. لا.
Maybe multiply by minus 1?
No.
You
this
add,
is what I will do.
You add R. You add D to R and increase D by 1. Decrease it by 1.
Right. Basically, what you said is similar to what I'm going to do now. Isn't this the same as, minus 10 multiplied by 11 minus 1 plus 10 plus 11 minus 11. مظبوط ولا لا؟
Yes.
صح؟ طيب. So now what I want you to do is consider these as one number. Oh, by the way, this is not right. Let me erase. Oops. Let me erase. Okay, -1. I said +11 minus 11. Right. Now, how can you add these two numbers? -10 multiplied by 11 minus 11. Isn't this the same as -10 multiplied by 11 plus -1 multiplied by 11? صح ولا لا يا شباب؟
Sorry, Doctor. Can you repeat again?
طيب.
The last
when
thing.
I have -10.
Result.
Yes, -10 multiplied by 11 -1 minus 11. Isn't this the same as -10 multiplied by 11 plus -1 multiplied by 11?
Yes, it's the same.
Yes.
Right. Can I take 11 as a common factor?
Yes, we can.
طيب. What will be the coefficient of 11?
-11.
-11. تمام. So now if I go back, this is equal to -11 multiplied by d, which is 11, plus, now what is -1 plus 11?
10.
10. طيب, who is 10 less than 11 greater than or equal to 0?
Yes.
Yes. So what is the right answer? So therefore, Q is equal to أيوة -11 will R is equal to
10.
will R is equal to 10. واضح يا شباب؟
Can we do it in the regular way, the regular division way, the chair division way? Like,
how do you want to do it that way?
كرسي مثلا قسمة كرسي.
عليكم السلام ورحمة الله. أيوة.
أقدر صح؟
قول لي how do you want to do it?
بشوف هذه بحلها الحين في ورقة بشوف.
طيب. Okay. So this is basically so remember that the remainder should always be non-negative. The remainder should always be non-negative. طيب. So find A div M and A mod M when A is equal to 228, M is equal to 119. طيب. And would you like to solve? يلا on the chat يا شباب. Let's do C. Since this is negative, what is the value of Q? What is the value of R? By the way, Q مش هي نفسها A div M?
Yes.
Will R is the same as A mod M, right?
Yes.
يلا. Q is -3. R is 102. Why do I feel that this is not the right answer? See, -3 multiplied by 333 is -999 صح؟ ترى هذا -10,000 ما هو -1,000. مظبوط يا زياد؟ طيب. So what do we do in this case? What do we do? So what I will do here to solve this is, well, let me find, 10101. Let me divide it by 333. Okay, I will get a number, and then I will reduce it by 1. Okay, I will get a number, and then I will reduce it by 1. So, so what do we have here? 10 divided by 101. Well, let's say, does 4 work? So 3 times 3 is 3. 3 times 3 is 3. Okay. So this is 999. طيب. So 10 minus 9 is 1. 10 minus 9 is 1. And this is 0, صح؟ بطلنا نعرف what's happening. 10 minus 9 is 1. 10 minus 9 is 1. 0 minus 9. 10 minus 9 is 1. تمام؟ Okay. So now I bring the 1. And 11 divided by 3 is how much? Is a 3, صح?
Yes. The remainder.
So basically 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. تمام. So 11 minus 9 is 2. 0 minus 9 does not work. So 10 minus 9 is 1. 0 minus 9, 10 minus 9 is 1, right? So,
Doctor, the first
basically,
deduction is not correct.
The first is not correct. Which one?
The deduction, 10,101 minus 999.
10,000 minus 999 is not correct. قديش بيساوي؟
Because it's not minus 9,000, so it equals 1,000. It's minus 900. So it's got to be 9,000 something.
ما فهمت عليك. عيد.
It's 10,000 minus 900. How could it be 1,000?
It's 10,000
minus 900
minus...
something.
No, but this is only the first 4 digits, صح? Just a second. Yeah, because this is 999. This is...
No, the answer is 30, doctor, not 33.
طيب. خلينا نسويها مع بعض. So 101 I cannot divide it by 333, صح؟ طيب. So 3 times 3, this is 9. 3 times 3, this is 9. مظبوط. و 3 times 3, this is 9. Now I have 1010 minus 999. مظبوط ولا لا يا شباب؟
10,000 or 1,000.
1010 مش 10,000. الواحد هداك لسه ما دخلناه. I'm
صحيح.
doing long division.
صحيح.
I'm doing log division يا شباب.
الريميندر 11.
فالآن 10 minus 9 is 1 صح؟
صح.
والزيرو oh the remainder is 11 مش 111.
Yes. 11.
Yes, the remainder is 11 not 111. صح هذا هو تمام مظبوط. So the remainder is 11, right? The remainder is 11. طيب now I bring the 1 صح? So 111 divided by 333 is how much?
One.
You add zero down and zero up.
Zero صح? Zero. So now basically 0 multiplied by 333 is 0 and the remainder is 111. So I have 10101 is equal to 30 multiplied by 333 plus 111. مظبوط؟ طيب now I need it negative صح؟ فأنا what did I say? I said to find R and Q, let me remove the ones below. To find R and Q, I will do minus 1, 0, 1, 0, 1. I will do it such that I will say this is minus 31. I will subtract 1 because I want the other one to be positive, not negative, صح? يعني if I multiply by minus here, this will become ايش؟ minus 30 and this will become minus 111. مظبوط ولا لا؟
Yes.
If I multiply the whole equation by negative 1, minus 10101 is equal to minus 30 multiplied by 333 minus 111. فأنا I need to make it positive. I need to make the remainder positive. How do I make it positive? Well, instead of minus 30, I will consider minus 31. Okay? I will consider minus 31. And what do you think the remainder is going to be equal in this case? Well, it's going to be the 222, صح? Which is 333 minus 111. 333.
So we...
Yes.
So when we change the sign of the 10101,
yes,
we add to 31 and we double the remainder.
The remainder we just say 333 minus whatever you have. يعني let me rewrite it. See يعني
I mean
I have minus 10101 equal minus 30 times 333 minus 111 صح؟
Yes.
طيب I want instead of minus 111 I want positive. طيب how do I get the positive? Well, add subtract 333 صح؟
What do you mean by that?
يعني
قصدك
yeah. Subtract 333 so it becomes minus 31 instead of minus 30 صح? And add 333 to the other term. واضح؟
واضح.
Subtract 333.
Yes. So I subtracted 333 here and I added 333 here. So I did not change the equation.
I got it.
تمام. طيب.
30 which
Okay, so
30 ايش وانا فيها عشان تصير 31
ماني سامع منيح.
30 ايش كيف تصير 31
انا شو سويت؟ مش انا عندي minus 30 multiplied by 333 وعندي هذا minus 111 I want to make minus 111, I don't want it negative, I want positive. طب how can I do it positive without changing the equation? I said, okay, subtract 333 from the first term and add 333 to the second term. Subtracting 333 from the first term is the same as, instead of minus 30 multiplied by 333, it becomes minus 31 multiplied by 333. صح ولا لا؟ والminus 111 exactly, it's like the 11 example. Okay, it's like the 11 example, but it's a little bit more elaborate. طيب. Okay, now in some situations we care only about the remainder of an integer when it is divided by some specified positive integer. For example, when we ask what time is it going to be after 50 hours from now, what will the answer be? Right now it is 1 p.m. صح? Or it is 13 on a 24-hour clock. Currently it is 13 صح? 13 and 25. طيب, after 50 hours, how can I do it after 50 hours?
The cycle is 24.
It becomes exactly 15. It becomes 1520. Well, according to me, it's 1526. It becomes 1526 or 1528. ليش 15? Because 50 hours, well, when you add 24, you will come back to the
same place.
صح? The same place. طيب, when you have two 24s, what is the remainder of 50 from the 24?
12.
The remainder is 2, صح? So 13 plus 2 is 15. So this is why we need, so this is kind of motivation, you know, for modular arithmetic, is that we do use modular arithmetic, okay? طيب. Now, if A and B are integers and M is a positive integer, then A is congruent to B modulo M if M divides A minus B. Okay, we say that A is congruent to B modulo M if M divides A minus B. If M divides A minus B. So for example, let's look at 7 and let's say and 17. Okay, this is A and B, this is A and this is B, and let M be equal to 5. Let M be equal to 5. We say that 7 is congruent to 17 mod 5 if the 5 divides 17 minus 7 or 7 minus 17. Does 5 divide 7 minus 17?
Doctor, what does congruent mean?
Congruent is like equal, is kind of equal. يعني you can consider it like مثل. يعني just like, you know, when you say
approximately equal.
Yeah, something like that. Something like that. No, مش approximately equal. It's equivalent, but in a different sense.
Is it like comparing an integer to an integer? Yes.
It's equivalent. It's equivalent, but in a different sense. يعني مثلا when I say the time after 2 hours or the time after 14 hours in a 12-hour clock, aren't they the same?
Yes.
Yes.
They have the same reminder.
They have the same remainder if you want. They have the same remainder, but they are, in some sense, they are kind of equal. And we will see that, inshallah. Okay? And we will see that. So we use the notation A is congruent to B mod M. That's why we are using, you know, we're not using equal, we are using 3 lines, right? We're using 3 lines to indicate that A is congruent to B modulo M, and sometimes we just say mod M, okay? We just say mod M. We say that A is congruent to B mod M, that this is a congruence. This is called a congruence, right? When you say A is congruent to B mod M. طيب, when I use, you know, this is on the side. When I use, you know, A equal something, what do I call this?
Constant.
Equation. I call it equation. Huh? So this is an equation. This one is a congruence. Okay. طيب, if A and B are not congruent modulo M, we write A, you know, and then we just put a slanted line to indicate that they are not congruent, right? A is not congruent to B mod M. So 6 is not congruent to 17 mod 5.
دكتور,
is not. نعم.
the congruence differs based on the value of M. It could be a congruent to each other with the one M and not congruent to another M.
Exactly. Exactly. Everything is related to the mod that we specify. So 7 is congruent to 17 mod 5, but 7 is not congruent to 17 mod, let's say 7. Are they congruent? 7 mod 7 and 17 mod 7?
No.
Doctor?
No.
They are not congruent.
Doctor, can we say 7 equals 17 mod 5?
Yes. And we will see that actually, we will say it explicitly here.
Doctor.
See, in theorem 3, it says let A and B be integers and let M be a positive integer. Then A is congruent to B mod M if and only if A mod M is equal to B mod M. So if A mod M is equal to B mod M, A is congruent to B mod M. And giving the example of 17, 7 and 17 mod 5. So 7 is congruent to 17 mod 5 if and only if 7 mod 5 is equal to 17 mod 5. What is 17 mod 5?
2.
2. And what is 7 mod 5?
Also 2.
Also 2. It's also 2.
Doctor.
نعم.
For A and B, if one of them was negative, should we only take A minus B?
Yes, it's always A minus B, even if A was negative.
Okay.
In fact, 7 is equal, so 7 is congruent to minus 2 mod 5. Is it? 7 plus 2, 9, لا, minus 3. 7 is congruent to minus 3 mod 5. Why? Because 5 divides 7 minus 3, which is 10. Okay, so 7 and minus 3, when you do your arithmetic mod 5, they are the same. طيب. Theorem 4 says let M be a positive integer. The integers A and B are congruent modulo M if and only if there is an integer K such that A is equal to B plus Km. Now, who can tell me what is the proof for theorem 4? It's kind of very straightforward, by the way. What's the definition of A and B being congruent mod M? A is congruent to B mod M if and only if M divides A minus B, صح? طيب ايش يعني m divides a minus b؟
K
A minus B divided by M.
يعني a minus b is equal to k multiplied by m صح؟ where k is an integer. مظبوط ولا لا؟
Yes.
Yes.
طيب. So therefore a is equal to b plus km. مظبوط ولا لا؟
Yes.
طيب. Now let's come to theorem 3. Now I made the big mistake in theorem 3 by trying to prove it starting from a congruent to b mod m implies, you know, a mod m is equal to b mod m. It's actually easier to, by the way, when I say a congruent to b mod m, if and only if a mod m is equal to b mod m, how can I prove it? I need to prove it in both directions, صح? Unless if the statements that I put are equivalent. Okay, unless if the statements that I put are equivalent, by saying, for example, you know, if this is equivalent to that, then I know that I can go both ways. This is something that you have taken in ICS 253. طيب. So here, the best way to prove it is actually to start from the second one. Is if a mod m is equal to b mod m. Okay. Now, what do we know if a mod m is equal to b mod m? From the division algorithm. And a mod m will be mod m is what?
R.
Is r, صح? And a mod m will be mod m is r, right? So therefore, when I put here a mod m is equal to r, so a is equal to q1 m plus r, صح ولا لا؟
صح.
طيب. Well, b mod m is also equal to r, right? So b is equal to q2 m plus what? Again, r, because it's the same r as a mod m, right?
Yes.
طيب. Now, if a is equal to q1 m plus r, will b is equal to q2 m plus r. Isn't this equivalent to, مش بس implies, it is equivalent, is it equivalent to what?
Congruent.
That, you know, a minus q1m is the same as
B minus QZM.
No, I want a minus b, صح؟ لأنه إحنا بدنا نثبت الcongruence، مظبوط؟ We want to prove congruence. طيب. We want to prove congruence. So let's look at a minus b. So if a is equal to this, b is equal to that, then a minus b is equal to what?
Q1m minus
Q1m minus Q2m plus r minus r.
Yeah, it will be a minus b equal to m multiplied by q1 minus q2.
Which is equal to m multiplied by q1 minus q2. طيب وال q1 minus q2 هذا ايش ماله؟
is an integer.
Is an integer, صح؟ طيب. So m divides a minus b ولا does not divide a minus b?
It divides.
It divides a minus b, right? So basically, this is the same as saying that a is equal to b mod, a is congruent to b mod m. Okay, this is the same as a is congruent to b mod m. So going from, you know, from this side, going from this side to the other, to this side is actually much easier than way around. is much easier than the other way around, and my AirPods now are gone. إن شاء الله بس الصوت ما يكون صار سيء. كيف الصوت يا شباب؟
No, I think it's actually better.
It's perfect.
الصوت ممتاز. طيب الحمد لله. Okay. طيب. So let's do a couple of these examples. So what time does a 12-hour clock read 80 hours after it reads 11? يلا يا شباب. On the chat. So basically, what did you do? What is 80 mod 12?
8.
80 mod 12
8
is equal to 8, صح?
Yes.
80 mod 12 is basically equal to 8. So basically 11 plus 8 is 19. 19 minus 12
7
is 7. So this is basically 7 p.m. Okay. Based on yeah. I mean, if we well, I don't know why did I say PM. We don't know, صح? لأنه هذه 11 could be AM or PM. Okay, so basically the answer is 7. And similarly, you can do, for example, B and C. طيب. Oops. What happened? Okay. طيب. Now let's look at theorem 5. Let m be a positive integer. If A is congruent to B mod m and C is congruent to D mod m, then A plus C is congruent to B plus D mod m, and AC is congruent to BD mod m. Can anybody tell me what does this theorem tell us? In fact, not only this theorem, let's also talk to the, let's go to the corollary. Let m be a positive integer and let A and B be integers. Then it says here that A plus B mod m is the same as A mod m plus B mod m all together mod m. And AB mod m is A mod m multiplied by B mod m all together mod m. This theorem and this corollary, what do they tell you? Any guess?
It's a properties for the congruence.
Properties of the congruence. طيب, doesn't it tell you that you can actually add and multiply whether before, doing the congruence or after doing the congruence?
Yes.
This is exactly what it says. The theorem and the corollary, this is exactly what they say. Okay. By the way, their proofs are very straightforward. You can check the book. They are very straightforward. But let me try to do the last thing here, which is basically do this example. Suppose that A and B are integers. A is congruent to 4 mod 13. B is congruent to 9 mod 13. Find the integer C with C between 0 and 12 such that C is congruent to 9A mod 13. Okay, so I want C basically mod 13, صح? I want C mod 13. So 9A. What is 9A?
AB.
Multiplication.
It's a multiplication. So it is 9.
9 4 mod 13.
9 multiplied by 4 mod 13. صح ولا لا؟
Yes.
9 multiplied by 4 mod 13. طيب. Now, what is this equal to? This is 36 mod 13, صح؟ مظبوط؟
Don't we have to follow the theory?
كيف يا دكتور؟ مو مفترض أول شيء 4 mod 13 بعدين multiplied by 9.
هي 4 mod 13 multiplied by 9 mod 13 نفسها 4 times 9. مش هيك الثيورم هذيك اللي بتقول؟ What is it? This one. AB mod M هي نفسها A mod M times B mod M. if you want A mod M times B mod M هي نفسها AB mod M.
Okay, I see now.
Okay. يلا يا شباب. What is 36 mod 13?
10.
13 plus 13. So it is 10, صح?
Yes.
Yeah.
Yes. 10.
It is 10. طيب. Now, let me use the previous corollary to try to arrive to 10 in a different way. معلش, I'll keep you لأنه we wasted some time يعني in the beginning. Just bear with me for a couple of minutes. طيب. هلا 9 mod 13 مش هو نفسه minus 4 mod 13.
Yes.
ترى 9 mod 13 وال9 plus 13 mod 13 وال9 plus twice ال 13 mod 13 وال9 plus 3 times ال 13. Okay, all of these numbers 9 minus 13, 9 minus 2 times 13, all of these have the same ايش؟ the same value mod 13 صح ولا لا؟
Yeah.
مظبوط يا شباب؟ So 9 mod 13 is minus 4 صح؟ So I can say here minus 4 times 4 mod 13. Minus 4 times 4 is how much?
Minus 16.
Minus 16. طيب minus 16 mod 13 is equal to what? مش هي نفسها minus 3 mod 13?
It's 10.
Which is 10. This is the significance. This is the significance of, you know, the previous theorem and corollary. This is the significance of the previous theorem and corollary. So, معلش, I kept you for a couple of minutes more, but we had a problem يعني in the beginning. I hope that you forgive me for that. واضح يا شباب؟ Any question? Any question? Inshallah, we will come back to part E and E. Inshallah, this is where we will start. Inshallah, next week بإذن الله.
دكتور,
Okay.
minus 3 mod 13. How is it 10
علوا صوتكم ماني سامع.
minus 3 mod 13. How is it 10 mod 13?
Well, it's the same. Minus 3 mod 13 مش احنا طلع فوق. مش احنا قلنا ال9 وال9 plus 13 وال9 plus 2 times 13 وال9 plus 3 كلهم they are the same.
Yes.
Similarly الماينس 3 هي نفسها minus 3 plus 13 هي نفسها minus 3 plus 2 times 13 هي نفسها minus 3 minus 13 وهكذا. They are all the same mod 13. واضح؟
هذه نقطة واضحة، لكن كيف التن جت؟ ما فهمت.
خلاص ما هو طالما انه minus 3 mod 13 add 13
Yes.
minus 3
اوكي
صارت 10 وال10 هل هي بين الزيرو وال12؟
يس.
خلاص we're done. فبدل ما تحسب 36 وبعدين تحاول تطلع انه 36 you know to reach 10, you can actually if you can you know safely you can safely you know like make the numbers smaller, deal with the smaller numbers, you will get the result faster. صح ولا لا؟
ايه ممتاز.
إن شاء الله we will see that in part D and part E, and also there is another يعني there's another exercise that we will carry out إن شاء الله next time. طيب يا شباب.
Thank you دكتور.
يلا يعطيكم العافية. نراكم على خير إن شاء الله.
بعد إنك دكتور له سؤال بس.
تفضل خليني بس let me close the stop the recording.